Is my sound working? Yes, it is. Okay. Hey guys, just kind of messing around with a few settings here, but what was I going to say? Welcome to level 2 tutorial. What I was going to say was I know I was supposed to do the level 1 today, but after this morning's last night's announcement that the MCAT is going to be delayed, I thought it's only fair that we kind of venture out into the level 2 territory, just to kind of do some level 2 stuff. Just to kind of get a bit of a gauge of people here. How many of you guys have actually attended my level 1 tutorials? If you have, just chuck up some sort of, I don't know, like a yes or I guess this is not the same as Zoom. I know I could put up a little thumbs up there, but yeah, I don't know. You know what? Forget about it. It's too much work. So what are we going to do? We are going to be doing some very quick intro to algebra. I'm particularly looking at level 2. So the ones that we're going to be today that we're going to be looking at is just powers and logs. And yeah, thanks, Rahul. We're going to be looking at powers and logs, and I think if you guys would remember last year, I did the same thing as well. Basically, what I'd do is I would cover like one little um, subtopic of the standard, and then slowly work our way from like achieved to merit to excellence and so on. I do apologize. My what do I gotta say? I gotta say that my tablet is getting very old, and on the odd occasion it does crash. So I might be writing, I might be saying stuff, but things might not be showing up on the screen. So just yell it out in the chat, and I'll just restart it, and then we should be good to go. So today's question, what we're going to be doing is we're going to be doing these three types of question here, which tend to be your achieved questions. And then we're doing a little bit of these types of questions where we're going to be using logs. Again, going to be achieved type of questions. And then straight away after that, we'll go try some merit and excellence questions. Now, we might not be able to get to the excellence questions, but that's all right. I will try and kind of carry on from where I left off from with the next tutorial. And I know you guys are probably wondering when the next tutorial is. At the moment, there are some negotiations going at my home because it does take into my TV watching time at this point. So we'll figure something out. All right. So I hope you guys had a kind of enough chat. Let's get to work. Hope you guys had a turn to maybe try some of these questions. So what I'll do is I might just start these questions in about, what is it, 7:33? So let's say 7:35. I'll start doing these three questions. Now, if you don't know what you're doing, I'll tell you what, just write some wrong answers, because I kid you not, that is the best way to learn is make mistakes, and then we learn from our mistakes. But I don't want you guys to do is, if you're just watching this, just kind of make some mistakes. That's absolutely fine. Hey, of course, we got to do a shout out for Father Tim. It's the second time this week that I've shouted out for Father Tim, I believe. I'm still waiting for Father Tim's YouTube channel, because that's got to be legendary, right? Yes, Jay, this will be available on, I guess, on demand. It will pop up later on after I finish the stream. It'll be back. It should be on my channel. All right, we got a half a minute, guys, before I kind of go through with this. I'm not gonna lie, it's actually nice to see some year 11s here, just to kind of mess around. Trust me, even though you're year 11, if you might have not done some of this stuff, but just hang around. I'm sure you'll pick up a few tricks for MCAT as well. Now, I realize that, Fatima, but hang around, you might actually pick up some tricks. Because you never know with the MCAT, right? They always They always kind of throws a few questions here and there. Okay, so at 7:35, let's get through with these questions, all right? So the first question here, what we've got is we've got the 3x to the power of -2. Now, some people, when they see the negative power, they go, okay, straight away move everything to the denominator. So just remember that the negative power in this case, the -2, is only going to affect the 3x. It's got nothing to do with the 4. 4 is by itself, and it has a positive power of 1. Because remember, anytime you have a number, the number by itself, and if it's in the numerator, it's going to have a power of 1. So if that's the case, then we can simply move the 3x to the denominator, but instead of -2, now it's going to be +2. All right, so that's the first step that you have to do. If you want to get rid of a negative in a power, what you have to do is you have to either bring it to the denominator, and if it's in the denominator, you got to bring it to the numerator. So basically, when you switch either from the top to the bottom of the fraction, the power sign actually changes. So now that we've done that, our next step is to do 3x squared. And again, this is something that I've done in level 1, and I'll probably do this in level 2 as well. I always ask people to chuck a 1 where the 3 is and the x's as well. Just because sometimes it's very easy to forget, and people end up doing something like this. So they'll write this answer as 3x squared, which is very common that people do this. Just remember that it's actually not correct. So what you have is you've actually got 4 to the power of 3 to the power of 1 times 2, and then x to the power of 1 times 2. Now you don't need to do this step. You could actually go straight from like the second line to the fourth line, because what is the fourth line going to look like? It's going to look like this: 3 squared x squared, and of course 3 squared is 9, so we can simply say that this is 4 over 9x squared. So what I was talking about before was you could potentially go straight away from here to here, and that's absolutely fine. So it's a nice little achieved question to kind of start off with. And the odd occasion I've seen this easy, but I do see the question B and C pop up as well as for an achieved. Cool, so let's go to question B. Now, what happens when you have a fraction inside a bracket and it has -3 as a power? Now, this one is a lot more easier to deal with because, again, like I said, if you want to change the power, no, I didn't delete the answer. I actually deleted the wrong answer, but that's fine. What you can actually do is I just say flip the bracket. All right. If you want to change the power, the sign of the power, you flip the bracket. So all I've done, or what I mean by flip the bracket, is take the numerator to the denominator and bring the denominator to the numerator. So this will become 2b squared divided by 3a to the power of 4, and now it's changed to power of +3. All right, so that's something that you need to just remember. Like anytime you're dealing with a fraction and a negative power, all you got to do is flip the fraction, change the sign of the power, and then we are good to go. So now that we've done that, once again, don't forget that individual elements inside the bracket, they all have powers of 1. If there's no power written there, I always ask people to get into the habit of writing a 1 for things that don't have any powers. Because in the next line, what we're going to do is 2 to the power of 1 times 3, b squared times b to the power of 2 times 3, and then we've got 3 to the power of 1 times 3, a to the power of 4 times 3. Now 2 to the power of 3, that's equal to 8, and then b to the power of 2 times 3 is b6, divided by 3 to the power of 3 is 27, and then a to the power of 12. Okay, now we go to question C. So question C is a little bit different. And again, with question C, you can actually do it multiple ways. You could actually expand the bracket, like bring the power inside the bracket first, or you could actually simplify whatever's inside the bracket first. Now, if you look at, in this case, what I'm going to do is I'm going to simplify inside the bracket. Now, we've got p to the power of 8 and p to the power of 10 in the denominator, which means this could be rewritten as 25. And what is it? We've got p8 divided by p10, so that's going to be p squared in the denominator. All right, now the power is still going to be 3 over 2. Nothing's really changed there. So the next thing is 25. Make sure you put 25 has a power of 1, which means when we take the bracket, get rid of the bracket, we're going to get 25 to the power of 1 times 3 over 2 divided by p to the power of 2 times 3 over 2. Now 25 to the power of 25 to the power of 1 times 3 over 2. Let me just do that one extra step here. So you've got 25 to the power of 3 over 2, and p to the power of 2 times 3 over 2 is just 3. So I've got to work out 25 to the power of 3 over 2. And again, I'm going to use the calculator for this because I want to show you guys some of the more common mistakes people do when they use the calculator for these types of things. All right, now, so when you go into your normal main menu, just go into your calculator mode, and what I see people do is they do this: 25 to the power of 3 over 2, like this. All right, now that's your number there. You can actually click on F to D, which changes from fraction to decimal. But here's the kicker, though. The kicker is you have to put brackets around the power, and that's why I'm showing you guys both the mistakes. Mistakes people do, and then what happens if you put the bracket. Because if you put the bracket, you will get the actual answer, which in this case is 125. Okay, so whenever you're dealing with powers and fractions in powers, always use the brackets to calculate in the calculator, right? So you got to use brackets for that. So our final answer is going to be 125 over p cubed. Cool. So what I'm going to do right now is let me know if you guys are happy with these three and you want to move on. Otherwise, I'm happy to give you guys a couple of more questions like this so you can have a bit of a practice on your own. Yeah, so we got a bit of time. So let me know what we want to do on the chat. So move on, or a couple of extra questions. Yep. All right, so I'll do one more one, as I know people are trying to copy things as well. Let me see if I can try and do it this way. So you might be able to actually see question 2A for those guys that are wanting to carry on. Okay, one more question here for you guys. Just question D here. What should we do? Makise, yeah, you could do that as well. So if you had actually done 25 as 5 squared, then you would get 5 squared times 3 over 2, which would then give you 5 to the power of 3, which is equal to still 125. Okay, shout outs to Luca Marinojo. There we go. And of course, Father Tim's Maths. I still need to know who this Father Tim is. Calviru, what I'll do is, I haven't shared this notebook yet. While we're doing the next lot of questions, what I'll do is I'll set up a link so that I can share the link to you guys. which means you'll be able to access these notes that I'm writing on my tablet live. So you could have like a tab with the video rolling on YouTube, and then you could have another tab with the notes popping up. All right, guys, I'm going to go through question D really quickly, and then we're going to move on to question 2A and so forth. So with question D, again, same thing. What I might do though is I'm going to get rid of that A. That's a terrible A, by the way. I really should have written it much better than that. That's all right. We'll just kind of work through that real quickly. So what we've got is we've got 16b3 divided by 9a. And now that's to the power of half. Yeah, it's just square root, but you know, when we're dealing with these indices, we can still use half. So we're going to get 16 to the power of half, b to the power of 3 times half, over 9 to the power of half, and a to the power of half. Now 16 to the power of half is just 4, because its square root of 16 is 4. And then we've got multiplied by b to the power of 3 over 2, divided by 9 to the power of half, so that's the same thing as square root of 9. So we're going to get 3, and then a half is what we're looking at. So again, like if you forget it, you can always put it in the graphics calculator. 16 to the power of a half is going to give you 4, and then 9 to the power of half. Oh, made a mistake. Oops. That's what happens when I try to type in too fast. There we go. 3. One more. Now look, we'll kind of mess around with these types of questions, all right? So we'll come back to it again later on, but it's just we'll try and learn a few more things as well today, but we will come back to it. Okay, so the next lot of questions that I have for you guys is these ones here. What I'm going to do is I'm going to give you guys some time to have a play around with this. Now, or do you guys want me to just go through the answers and then give you guys questions after that? So if you need some time. Yes, that is correct, Johnny. Denominator is the root degree and numerator is the index. Yes, that's correct. Numerator is the index. Denominator is the root degree. Yep. All right, so we'll actually go through these questions. Now, for those of you guys that do have a graphics calculator, this next lot becomes very, very handy to have in a graphics calculator. But however, the way I'm going to show you guys is I'm going to show you guys both methods. I'm going to show you guys how to do it in the graphics calculator, but I'm also going to show you guys how to do it using the long method. Now, why do we do the long method? The reason we do the long method is some of the questions that I have for you guys later on today will be in the merit excellence area, and then those, they tend to not, how do I put it, they put like rearranging questions, so you have to actually rearrange it with letters, and so therefore you must be confident with the rules. So that's why they try and kind of shift away from giving you guys really easy questions like this for merit or excellence. However, we do have a graphics calculator, so we can actually check our answers. Now, the first thing that I want to tell you guys or show you guys is this, which I think you guys get this in the formula sheet. Let me just see if I can find it. So if you ever forget it, you could always go back and look for it. Level 2 formula sheet. Which one do you guys get given? Okay, you guys get given this one here. Just give me a second. I'm going to try and see if I can get this right. Okay, so what do we got? Add source, screen capture, window, level 2 maths. All right, there we go. So as you guys can see, your log rules are actually given in your formula sheet. So if you ever forget it, you always go to the formula sheet and just use the formula sheet, and then you should be good to go. But in fact, I think for us, what we're going to be doing is like we're going to be using just Which rule are we going to be using? Yeah, the one I'm going to show you guys, it's like it still works, but you can still use my method as well, so it's fine. So let's just get rid of that for now. So how do we do the first one? So looking at the graphics calculator first, I'm going to show you guys in the graphics calculator first. So in your graphics calculator, I still get annoyed by this because you guys have like devices that can do so much more things, but unfortunately we're still using this graphics calculator. That is the way of things. But anyway, we're going to go into this little mode called equation, all right, which is right after conics. And we're just going to click on equation and click on F3 for solver. So F3 right there, we click on solver. And then if you look at our question, it's 3 to the power of x equals to 12. So I'm just going to put that in here, 3 to the power of x. And the equals button is shift and the little decimal point. Put it equal to 12 and press enter. Now, initially, it's going to pop up with x equals to 0. What you need to do is click on the solve button. When you click on the solve button, it should actually tell you what the answer is. Right now, it says the answer is 2.26, blah, blah, blah. Okay? Now, how do we know whether this is right or wrong? Well, actually, you do know. Because think about it like this. If I have 3 to the power of 1, that's equal to 3. If I have 3 to the power of 2, then it is going to be 9. And 3 to the power of 3 is going to be 27. So now the calculator is saying somewhere around 2.26, which, yeah, kind of makes sense if I look at how the table is actually looking. So I already know the answer that I'm looking for is 2.26. Yep. I'll go through it again for the next one, Caitlin. So just to give you a bit of how do I do this? How do I do this? So let me just write the instructions down at the top there in the at the top. So you go into menu, then go into equation. You click on equation. Let's just exit out of this. So you should click on F3, which is solver. And then you literally just write the equation down. All right, so you write the equation down, which is, well, write equation, and make sure you click on solve, which is F6. Hopefully that helps there, Caitlin. Nice. But I'll go through it again for the next few questions. But anyway, how are we going to do this? Let's say we don't want to use the solver, but we just want to use it using logs. Then it's really, really straightforward, guys, because all we're going to do here is you can actually take log, or you can actually get, so if you got x equals to 0, make sure you click on solve. So this is what your equation should look like. You should have 3 to the power of x, and it has to be this x right here, or you could use the other x as well, that's fine. Shift equals 12. So when I do it, I've got to make sure I click on that solve button. If I don't click on the solve button, it will actually stay as 0. But anyway, we're going to go do this the other method, right, which is taking logs. So what I'm going to do is I'm going to take log of 3x and log of 12. Now, you guys probably used the log that's here on the graphics calculator, but you could also use ln as well. It really doesn't matter whichever one you use. And what I'm going to show you guys is both of them, and they're going to end up with the same answers, all right? So it doesn't matter which log you actually use, but it will still work out. So I'm going to use natural log here. Then what I've got to do is I can move the x to the front. All right, now this is a standard thing. This happens whether you use ln or whether you use log. So what's going to happen is I'm going to write this as x is ln 3 equals ln of 12. Now because of that, and x is getting multiplied here, I can rearrange this as x equals ln of 12 divided by ln of 3. Now if you remember, my answer was around 2.26, I believe, for question 2a. So here I'm just going to go ln of 12 divided by ln of 3. And as you can see, I'm getting x equals to 2.26. Now let's say, for some reason, you decide to go with logs. That's absolutely fine, because look, if I do log 12 divided by log 3, I should get the exact same answer as well. So it doesn't matter which one you use, you're still going to get the same answer. So in saying that, I'm going to get you guys to try question number 2b by yourself. So ln is right here next to the log button on the calculator. So why don't you guys try question number B, try it with the graphics calculator method, then try doing this method as well, and then see if you are happy with it. All right, because ideally I'm trying to get you guys to a place where you know you've got a backup just in case you feel like something isn't working out. So yeah, have a go with B, and I'll give you guys about 30-40 seconds, and then I'll get going with question 2B. Now at the same time, if you want practice with something similar to A, you could try this one as well. We call this F, maybe. Let's try that one. So Johnny, that's a really good question there. So when we're talking about log, we're actually talking about base 10. And then natural log is something called the exponential curve, which is more similar to like population growth and things like that. So it's just a different base, that's all. So if I was to take, like if I take log of 1, that's going to be 0, but I'm talking about log of 10, sorry. If I take log of 10, that's base 10, so it's going to be 1. And if I take, I'm trying to show you guys e to the power of 1, so ln of 1, what am I doing here? E to the power of 1 is what I want to show you guys. So e to the power of 1 equals 2.7. So that is, think about e, except it's like another, like it's like a pi number, it's like a recurring number, that's all. But they both have the same principles, like the same idea. So you're just taking it on a different base. Okay, so what I'm going to do is I'm going to do question 2b. Actually, I'm going to go 2f first, the 4x equals 15, real quickly. So I'm going to go log. Doesn't matter if I use log or ln. I'll use log in this case. So log 4x equals log 15. Move the x along to the front. So I'm going to get x log 4 equals log 15, and then x is equal to log 15 divided by log 4. Now, which is going to give me whatever it is on the calculator. Log 15 divided by log 4. So that's going to give me 1.95. And I know I'm correct because 4 squared is 16. So think about it like this. 4 squared is equal to 16, which means if I'm looking for something like 15, then this x has to be less than 2. So that's how I know I'm actually on the right track. Okay, so now on to question 2b. Once again, I'm going to take logs for both sides. I've got log 4x plus 1 equals log of 10. Now, because x plus 1, the whole thing is in the power, I'm going to have to move the whole thing in front of ln of 4. So what it's going to happen is I'm going to have a little bracket, x plus 1, ln of 4 equals ln of 10. Now rearranging it, I'm going to get x plus 1 equals ln of 10 divided by ln of 4. And then next one is I've got to get rid of the positive 1. So this is going to become ln of 10 over ln of 4 minus 1. Now notice how I haven't actually solved any of these ln's yet. And the reason is because I don't want to solve it until I have everything in one shot, and then I can just, so I don't have like rounding errors. So I'm going to do this in one shot. So we've got ln of 10 divided by ln of 4. which is whatever minus 1 gives me 0.661. Now, some people ask me about decimal, like how many decimals do you use? You know what, like that's a really odd question because it's like, we always say like, look at the context of the question. Now in these ones, I'll probably go to 3 or 4. Yeah, as long as you write, and I know some kids are so scared of decimals that they'll write the whole answer, and there's nothing wrong with that as well. Okay. Hopefully that answered your question, Calvero. Are we okay with question 2b before I move on, or would you guys like another question like 2b to have a go? So just shout out if you want to move on or another question in the chat. Oh yeah, I'll show you guys how to do this question in Solver. That's a really good one. So I'm going to go into menu and I'm going to go into equation. Click on Solver, which is F3. Now, of course, the previous question is still going to be there. You can click on delete button and just get rid of everything. So you click on F1. Yep, I'll put up another one, guys. So in here, I'm going to go 4 to the power of x plus 1. Now, remember what we talked about earlier in this tutorial. Whenever we put powers and we have like a whole bunch of things, we want to make sure we put that in a bracket. So in this case, we need to make sure we put that x plus 1 in a bracket. Because if you don't put x plus 1 in a bracket, you are going to get a completely different answer. Now we're going to go shift equals, and we're going to put that 10. And we're going to click on enter. Now notice how it says x equals 2.26. That's because it was the last question's answer. So you just have to make sure you click on solve to solve this equation here. So I'm going to click on solve. And as you guys can see, I'm getting 0.6609. Okay, so another question very similar to 2b for you guys, but I'm going to call it 2g. And let's try this one here. So I'm just adding like little bits and pieces extra for you guys. Simran, as I said it when we were doing the calculator parts, is that if you do get questions like this, you know, you can actually use the graphics calculator, but the reason why I kind of ask kids to get into the habit of using logs is because you're going to get an excellence question and a merit question later on, which is going to require you to use these skills. All right, so my recommendation to people is that use the solver to check your answer rather than just put your answer straight away there. And trust me, by the time you do some of those excellence questions, these questions, when you see them, it actually takes more time to put it in your solver than to try and rearrange it and do it like that. That's how fast you guys will actually become. So I'll give you guys another 30 seconds to try question G. And you know, try the how I did it in question 2B. Have a go, and then we'll go through the answers. For equal sign, it's shift and decimal point. Saskia, no. You will get the same answer if you use logs, but don't make the mistake of doing this though. Like I don't think anybody does it, but you know, like say for example, let's see question number like F. So in F we did ln of 15 divided by ln of 4. Notice how it's the same thing as saying log 15 divided by log 4. But what you can't do is you can't do this. You can't go log 15 divided by ln of 4 because that screws it up completely. Okay, so Salty and Blessed, you guys have given me 2 answers there. I'm going to ask you guys to go check it on the graphics calculator to see which one is the right answer. All right, so that's the whole point of you guys having the graphics calculator is actually I can actually go and put this equation real quickly on my graphics calculator to find out what the answer is. And that way you know where you're making a mistake and you're going to learn from it. All right, guys, I'm going to go through question G now. So what have you got? We're going to do the same thing. We're going to take logs of both sides straight away. So we got ln of 2 to the power of 2x minus 1 equals ln of 12. And then next thing is bring the 2x minus 1 down to the front, which means we're going to get 2x minus 1 ln of 2 equals ln of 12. Rearranging it, so ln of 2 goes to the other side, it gets divided by ln of 12, and then we've got 2x is equal to ln of 12 divided by ln of 2, and of course that becomes plus 1. And finally, x is equal to ln of 12 divided by ln of 2 plus 1, and that whole thing is now divided by 2, which is going to give us whatever x is. So I've got ln of 12 divided by ln of 2 minus, no, plus 1, and that's all thing divided by 2. So as you can see, I'm getting 2.29 as my answer there. Hey, no, that's all right. I mean, like, blessed. That's the whole point of you having that graphics calculator to check the answer. And I'm going to show you guys how to do it in the graphics calculator as well. So go into equation, go into solver, delete the old equation. And what's my new equation? I've got 2 to the power of 2x minus 1. And that equals a shift decimal point. This is equal to 12. Click on enter and make sure you click on solve. And there we go. We got 2.29 as our answer. So, okay, next thing. Usually I keep word problems almost towards the end of the tutorial cycle because you know, it's no point attempting some of the word questions if you struggle, if you find the skills section challenging. So it is something that we will go through, and I just want to make sure that we get some of the basics covered. Once we cover that, we can actually go into some, I usually head down to like maybe tutorial number 6 or 7 that we start doing word problems. All right, so let's get through these questions here. Now these ones, they work slightly differently. Whoa, damn it, stuff that up. Just trying to move that and I couldn't, hang on. Why won't you work? Okay, one at a time then, fine. Give me 1 second, team. There we go. So what we've got is these 3 questions here. Now, I'm going to be honest with you guys. When you look at these questions, how do you go about solving this? It's probably, you know, yes, you can use logs for this, all right? And I'm going to show you guys how to do this using logs, because it is a hell of a lot of work, okay? But you know what? It's like, it's almost like, do I show you guys the long method, or do I show you guys the shortcut and just get it over and done with? Yeah, I think let's do the shortcut, because the long method is just painful to actually go through this. Yeah, level 2 calculus tutorials are available down there, man. Just go to my channel and have a look. So let's actually do this shortcut method. You know what? Long method, just for those ones that want to see how miserable this question is. So I'm going to do it on right about here. So long method first, and then I'll show you guys the short method, all right? So we got x to the power of 4 is equal to 40. So we're going to take ln. Yeah, ln is fine. Now let's just do this, whatever. Ln x to the power of 4 equals ln to the power of 40. Next, what we need to do is get rid of that 4 to the front, which means we're going to get 4 ln of x equals to ln of 40, and then ln of x equals ln of 40 divided by 4. Now, if you want to get rid of ln, you've got to use e to the power of x. So what's going to happen is here, we can replace this with x is equal to e to the power of ln of 40 over 4. All right, so if I use this in the calculator, so let's go back. I'll show you guys how it looks like in the solver first, right? So in solver, what do we got? X to the power of 4. So we can just put that straight away. X to the power of 4 is equal to 40. Press enter. Solve. There's my answer, 2.514. Okay, that's my solver. The next one I wanted to show you guys was this long method here, which is using exponential. So it's going to be e to the power of ln of 40 divided by 4. As you can see, 2.51. Now, if for any reason you use logs, then your x would look like this. X is 10 to the power of log 40 over 4. And I want to show you guys what happens there as well. So we've got 10. Oh, sorry, didn't realize. So we've got 10 to the power of log 40 divided by 4. Okay, and again, you're getting the same answer, 2.514. So how do we do this, the shortcut method? All right, the shortcut method is, as Makise, I'm sorry if I'm pronouncing it wrong. The shortcut method is actually converting the power of x into 1. So how do we convert this x to the power of 4 as x to the power of 1? Well, it's simple. What we're going to do is we're going to take a power and we're going to multiply both sides of the equation with that same power. Because remember, 40 actually has a power of 1. All right? And because 40 has got a power of 1, and if I want to convert this 4 right here, I want to convert this to a 1, all I got to do is multiply it by its reciprocal. So I'm going to multiply by a quarter, and I'm going to multiply by a quarter. Because when I do that, I'm going to get x to the power of 4 times a quarter equals, well, what am I doing? 4 times a quarter is just 1. And then on this side, I'm going to get 40 to the power of quarter. So if you go into your calculator and just put in 40 to the power of 1 over 4, you are going to get the same answer. All right? So this is what I meant by when we actually do the long method versus the shortcut method. All right? The shortcut method is basically you take the power to the other side and you flip it. You literally flip it. That's all you got to do. And you're done and dusted. Because let me show you how fast we're going to do question D. Question D, because it's 3/4, we're just going to write x is equal to 15 to the power of, it's going to use a different color, but being a pain, it's going to be to the power of 4/3. That's it, we're done. So now we can just say x is equal to 15 to the power of 4 over 3. So that's salty cage. I wouldn't even bother doing the long method because you're fine doing the shortcut method. The long method is only useful if there are variables involved. So where they don't have like numbers, but they have like a whole bunch of letters, then it's quite useful. But it is a handy little trick to have as well. Finally, question E. I think we were talking about this before. Our first step is to convert this from surd form to fraction form. All it means is this. This is just x to the power of 3 over 5, which equals to 8. And that means x is equal to 8 to the power of 5 over 3. When do you do the reciprocal of x? Is it always equal to 1? Yeah, because the thing is, the whole point of when you multiply a number with its reciprocal, we're always going to get 1. Because think about it like this, all right? If I take 5 and I multiply it with its reciprocal, which is 1 over 5, that cancels, it's 1. And if I take like the letter A, the reciprocal is 1 over A. A and A cancels, which means it's always going to be 1. Or if I take something like 3/4, the reciprocal of that is 4/3, cancels out, and you're left with 1. So that's why you always take the reciprocal and you multiply the reciprocal to make that power equal to 1. Cool. So we've got E done. That's 8 to the power of 5 over 3. Make sure you put that in a bracket. Oh, that's a nice question here. So we got 32. So that's pretty much some of the tricks that we need to know for logs, some of the tricks we need to know for powers. So what do you guys want a couple of more questions like this, or you think you got it, you're good with it and you can move on to the next one? Good to move on. Okay. How many of these questions do I have right now? Okay, so we're going to move on to one of the first kind of like merit/excellence questions. So I'm going to put that up here, and we are going to say make X the subject. What is happening to my writing today? So here's your first question, guys. So we're going to have, what is it, 8, 27. This is what I call chuck you guys straight in the deep end, eh? Now, this is something very similar to you guys would have done last year, where you had to kind of like rearrange these with the same basis and then try and work like that. So I'm going to leave you guys with this for like maybe a couple of minutes. Mess around with it, have a play around, but ideally, my final answer should be X equals to something. So X has got to be by itself. I did one last night, Jonathan. I did one for differentiation. Don't know when my next one is going to be. I'm kind of in negotiations with at the moment whether I do it during daytime or not. Well, actually, I should ask you guys, if I do one during lunchtime or something like that, would you guys jump on, or is that disturbing you guys with your normal school tutorials? Oh, very quiet crowd, but that's all right. The time schedule for these live streams are actually in my head, unfortunately. It's like some days I get up and I'm like, I'm tired. I can't do it. After school. Ah, okay. So say around like 3:34, you reckon? Yeah, it's possible to do a 3:30 to like around 4 o'clock one. The only thing is that you guys would have to listen to like old school cartoons in the background because my kid will be watching some TV unless I figure it out. Anyway, look, let's just go to this question first. So just a bit of a hint for you guys, just in case you've forgotten. Remember these numbers, 27 and 81. That's my hint to you. Because 27 is, you can rewrite these numbers as 3 to the power of something. I'm hoping it rings a bell, guys. Yeah, no worries, Jonathan. We'll sort something out, man. Depending on how long this lockdown goes for. Okay, so let me actually start doing this question, guys, because I know that it's been very quiet. Yeah, 3 and 4. Because remember, 27 is 3 to the power of 3 equals 27. 3 to the power of 4 equals 81. So that's the first thing that I got to do here. I got to rewrite this 27 as 3 to the power of 3 to the power of px plus 2 equals 3 to the power of 4 to the power of 4 minus x. Now, surprisingly, this question is not as challenging once I do a couple of steps, because you'd be like, what the hell? Why didn't I think about it like this? Because look at this right now. All you got to do is the two powers get multiplied. So we're going to get 3 to the power of 3 bracket 3px plus 2 equals 3 to the power of 4 times 4 minus x. Expand. Actually, we don't even need to, well, we can expand the brackets if we want to. But because the two bases are the same here, so remember that this base and this base is the same, we can pretty much say then the power, both of those powers must equal to each other. So we can just write this as 3px plus 2 equals 4 bracket 4 minus x. Now we need to expand, so we got 3px plus 6 equals 4 times 4 is 16, 4 times negative x is negative 4x. Now we rearrange, so we got 3px, what is it, equals 16. I'm going to bring the negative 4x to the left-hand side, change this to plus 4x. Take the 6 to the right-hand side, becomes minus 6. And what we've got here is, now we can't really combine anything on the left-hand side apart from taking x out as a common factor. So we're going to get x 3p plus 4 equals 16 take away 6 is 10. So x is equal to 10 divided by 3p plus 4. So as you guys can see, it is not, it's not as tricky. It's just understanding some of your rules and then kind of like messing around with it. So let me know, you guys, if you have any questions. What I'll do is I'll put up some line numbers. Usually this helps people. Let me know if there's any particular numbered line that doesn't make sense, and I'm happy to go through it again. Borderline merit. I think it's a merit, and I know a few years ago it was an excellence. Way back a few years ago, like about 4 or 5 years. Now they've dropped it down to a merit. I don't understand it why, but do these questions always have the same power? What do you mean by that, Salty? I don't understand that. Without doing line 1. Now you have to do line 1, Eileen, you have to do line 1, because without doing line 1, you won't be able to get rid of the basis. Well, actually, is there another way? Yeah, there is another way, Eileen. I can show you the other way if you want to use logs, the horrible logs. So Eileen's actually asked a very good question. Can we actually do it another way without doing line 1? We would have to take logs. So what will end up happening? You get log 27 px plus 2 equals log of 81 4 minus x. Oh yeah, now it's going to get quite nasty, eh? Because you got to do like, how do I put it? Yeah, it's not going to look pretty. It'll look pretty ugly, but it can be done. But it's very long. Where you can't get the same basis, not if, hang on. Where would the achieved be? Maya, the achieved, I would probably, no, I wouldn't think that, Salty, because I think that was at level 1 that you're expected to do that. So I would probably even be thinking, maybe even here, maybe I'm thinking achieved, because, yeah, just putting powers is not equal to just achieve. At level 1, definitely yes. Christopher, yes, I am. I teach at, well, I don't teach senior levels anymore. I don't teach level 1, 2, 3 anymore. I just do this because I kind of miss it every now and then to do the maths. I enjoy doing the maths not so much marking the exams or the internal assessments. I already did it, Harry. 2020 paper is already up. Have a look, man. Do you guys want another question like this, or do you want a different type of question? A different challenge, which will throw you off again? I'll tell you what, I'll give you one more like this, and then I'll throw you guys something, a curveball after that. I'm trying to think, did they make this as a... No, they didn't. It's all right, Harry. I haven't done the calculus one yet. I will do that sometime. So the question would only come up if the basis 3 are the same. Well, yeah, like Eileen, how they generally tend to do is like if they have like these types of questions, they will kind of give you basis that you can manipulate, or they could have something like, which I'm going to give you guys next, the next question for the night. But try this one first, and then I'll do the last one for the night before we call it. Harry, I've thought about it. Every now and then I'm like, oh, I should just write my own paper, and then I just get bogged down with all my other stuff that I end up doing. So hello, Viral. I haven't seen that name before. There's always one grammar police somewhere. All right, you guys want me to go through the answer yet, or are you good? Need more time? Gonna give you guys another half a minute, and then I'll go through it. X equals AN. I don't know where you got the N from. Oh, AB, okay. All right, guys, I'm going to go through the answer for this one now. So once again, I've given you guys kind of like the similar base. All right, so we got a couple of different answers. Cool. So it's going to be powers of 2, which means we can replace the 8 with 2 cubed and 16 with 2 to the power of 4. So what we have is 2 to the power of 3 bracket x over a plus b equals 2 to the power of 4 times b, which is just 4b. So now we forget about the 2's. We don't really care about it anymore because we've got the power. The two bases are the same. Because the two bases are the same, we can just put the two powers equal to each other, which means we're going to get 3 x over a plus b equals 4b. Now I'm going to expand the brackets. So I've got 3x over a plus 3b equals 4b, and then 3x over a equals 4b minus 3b. You just write that in a different color. So we've got 3x over a equals to b, which means I can now get rid of that a, bring it across. I'll do one more step there. There we go. 3x equals to ab, and then x is equal to ab over 3. So again, just be mindful, like, I mean, these kind of questions, they tend to be like merit questions. Easy, nice, easy merit questions, especially if you guys ever see like make the x the subject of the equation questions, just go, yep, this is my 5 points that's coming my way straight away kind of question. That's how you need to be thinking about it for. Let me just have a quick look at something here. Trying to see if they asked you guys a question like that last year. Yeah, last year's paper was not fun. I did not enjoy doing the video for that. Oh, this is incredible. Let me show you guys, what is it? I want to show you guys a merit question from last year, if it's all right. Can we just take a little break? I got AB over 3. No, that's fine. That's correct. Because A times B over 3 is the same thing. I want to show you guys this. This is from last year. I wonder if I actually have it here. Yep. Here we go. So this was last year's exam paper. And I just want to take you guys to this question here. Where did it go? Here we go. Look at that beautiful question. I reckon you guys would have nailed that question, right? Because that's a merit question last year. Basically 3 to the power of 4x equals to 30. I'm not gonna lie, man, that level 2 paper was just like, one thing that I always feel is that when it comes to exams, they shouldn't have like investigative type questions. And I know that they had one in this one, this question here, which was just super annoying. Yeah, I did not enjoy doing that question. Explaining it was just a pain. Here we go. Here's an achieved question, which is make x the subject of the formula. That's the part A. And then they've actually asked you guys to do something extra with it, which we'll actually do later on. But a simple rearranging one here, that's worth an achieved. Cool. Our last question for the night, which I promise you is going to throw you away. Yes, I intend to do it that way, but let me just grab that question. Yeah, this is going to throw you off. I promise you on that. But if you understand how to do this, then you're pretty much sorted with kind of manipulating these things. Yeah, let's do it this way. Yeah, I'm going to leave you guys with that question. So you're trying to solve this, all right? You're not trying to make x the subject. You're actually trying to solve this. And I'm going to tell you right now, this particular question is a trick question. It's supposed to make you think. So I'm going to give you guys maybe like a minute or two to go through this, because if you get this question, yeah, it's legendary. X equals -1. Really? Did you use solver for it, Mohammed? All right, all right, all right. So, how are you guys going with this one? I know there's random stuff happening in the chat. Harry, Chris, I can't believe I'm actually saying this, but I need to know if you're here to work, man. Ah, 10.31 with solver. Yeah, no, I'll give you some more time, Eugene. Would you guys like a hint to kind of have a go? The hint I'm going to give you guys is go back to this question here that we did. Where did we do this question? Your hint is this right here. This is your hint. What we did earlier at the start of this tutorial. That's the hint I'm going to give you guys. Because I guarantee it, you're going to be like quite annoyed that you didn't actually see that happening. So once again, the hint on the side I'm going to give you guys is this. That's the hint. Johnny, come back to the hint that I just gave up here. See if you can find a pattern. It's literally the first line. If I give you guys the first line, then you guys will be like, ah, that's not that hard. Is this a merit question? Yeah, probably would be a merit, yeah. No, this is not an excellence question. If you got 10.31, then yeah, you're on the right track. Okay, I'm going to show you guys the trick behind this question. Now, if you were trying to do like 2 to the power of something, yeah, it's not going to work because we don't have 2 to the power of something as 5 straight away. All right, so we can't actually replace that number straight away. But one thing that we do notice is we're actually going to go backwards in this case. So when I say backwards, notice how there's an x as a power in both of those elements. So this is the same thing as saying 5 to the power of 1 times x multiplied by 2 to the power of minus 2 times x. And if that's the case, then we can rewrite this as 5 to the power of 1 times 2 to the power of negative 2. Now that whole thing is to the power of x equals 10. And I hope you guys picked that up, because if you picked that up, then you pretty much got it after that, because the next step is 5 over 2 squared to the power of x is equal to 10. Now 5 over 2 squared is 1.25 equals 10, and then you guys are pretty much easy from there, because take log, so ln of 10. Now you might be wondering why I always use ln and not log. It's pure laziness because I don't like writing that extra letter of g. That's how lazy I am. X ln of 1.25 equals ln of 10, and then x is equal to ln of 10 divided by ln of 1.25. So chuck that in the calculator. We've got ln of 10 divided by ln of 1.25. There's your 10.31. So as you guys see, like it wasn't really like, it was just that one line that you guys needed to actually, yeah, you could have done the same as win. You could have done it with logs as well, like as I said earlier in the tutorial. So if you did log 10 divided by log 1.25, you are going to get the same answer as well. Yeah, so Johnny, I hope you got it now, because it was literally just that one little line that you have to get. Because if you get line number 2 there, then you're pretty much sorted after that. And that's why I kind of left this to the last minute. Hey guys, look, that's basically it for this session today. Just keep an eye on Instagram to figure out when our next tutorial will be. I will kind of have a chat just to try and figure out what we'll do in terms of like when we're going to do this next. But yeah, keep an eye on Instagram and I'll just get back to you on that. But apart from that, thank you guys for actually joining today. Yeah, I was going to do an excellence one, but I'm just keeping an eye on time. So I will catch you guys next time. I'll hang around for a couple of minutes just to answer some questions. But have a good one and stay safe.